Hi everyone, what's up? Today I want to discuss how you can choose a very good u value for a specific antiderivative, okay? So now this example up here, I think it's a really good example to show, the philosophy or the logic behind what u value you should choose for u substitution, okay? So in this example, you can choose u to be sine, but you can see that that's not gonna work. Well, I mean, it might work, but it's gonna be way too complicated because you're gonna get that du will be equal to cosine x times dx, and here you have cosine squared. Okay, so you might have to do something kind of complicated there. So that's not gonna be a good substitution if you choose sine to be u. Now, if you choose u to be cosine squared, well, that is also gonna be kind of complicated because you're gonna get that. If you choose u to be cosine squared, you're gonna get that du is gonna be equal to 2 times cosine x times sine x. Okay, this is just the chain rule. Okay, and you can see that. Well, you have an expression that is very similar to the integrand, okay? And if you're in an exam, you might be able to, and of course this is dx, you might be able to alter this expression in some way such that you can match this integrand, but it's not going to be a good choice, okay? It's going to take you too much time, and it's just going to be way too complicated, okay? So the two substitutions, u equals cosine squared and u equals sine, those are not good substitutions, okay? So now, something that you should actually do, and I think it's a notion or a strategy that many beginners in integral calculus, especially when they're just learning how to pick a u value, something that a lot of beginners don't do is that you can choose a u value and then adjust it to whatever you have in the integrand. So I'm going to show you this. You can say that u is not going to be any of these any of these expressions that you have here explicitly, but it's gonna be a portion or pretty much half of one expression that you have here, which is gonna be cosine. So instead of letting u be equal to cosine squared, you're gonna let u be equal to cosine, okay? And that is gonna be so much better because you can say that u is gonna be equal to cosine x. We know the differential of u is gonna be minus sine x dx. And you can see that right off the bat, this expression is pretty similar to what you have here. You just need to move this negative sign outside the integral sign. And now, instead of dealing with a lot of exponents and trying to alter a pretty big trigonometric expression, something that you can do is the following. So you're gonna have the antiderivative of. Now we know u is equal to cosine, but here you have cosine squared. So something that you can do and that is totally legal is to write u squared. Okay. This is something that once you realize that it's something you can do, it's something like pretty dumb, or well, I wouldn't say dumb, but that is just, it doesn't really require too much brains to be able to figure that out. But I think if you're a beginner, and well, it personally happened to me when I was solving this integral quite some time ago. I remember this was a very special one because you can get into a pretty big mess if you choose u to be equal to cosine squared or u to be equal to sine. Okay, so if you're a beginner, remember that you can choose u to be equal to a smaller or simpler expression than whatever you have here, and then you can adjust your u to match whatever integrand you have. In this case, u equals cosine, and we want to match this expression with cosine squared. And doing that in terms of u, well, it's just simply going to be writing u squared, okay? That's it. So yeah, this is going to be u squared times sine x dx. We know based on this equation that sine x dx is going to be equal to minus du. So we're going to get here u squared times sine x dx, which is going to be minus, I'm going to move the negative sign before the antiderivative sign, and this is going to be du, okay? And now this integral, it's pretty easy to solve. You would get a pretty wild integral if you chose any other substitution, and this one is super easy. So this is going to be minus u to the third power divided by 3 plus c, okay? So now this is just the antiderivative power rule. So this is going to be the same as minus cosine to the third power divided by 3 plus c, okay? So this is the antiderivative that we're looking for, okay? Now you can check this real quick. If you differentiate it, you're going to get minus cosine, the 3 exponent and the 3 denominator, they get cancelled out. And we're going to get minus cosine squared times minus sine x, and you can see the two negatives, they cancel out, and you get cosine squared times sine x, which is what we have here, okay? So yeah, now this is how you can solve this integral. The main idea of this video is to show beginners that you can choose u to be equal to cosine, and you don't really have to choose. I mean, you're not forced to choose cosine squared or sine x, okay? I know a lot of people, they just simply try to grab the entire expression. They think that they cannot grab the incomplete integrand, okay? So you have these two factors. You don't have to grab the two complete factors or one complete factor and let it be equal to u. You can just grab a small fraction of the factor, okay? That's my point in this video. And of course, if you already know some u-substitution, this is not going to be anything new, because once you realize that you can do it, well, it's pretty simple, I mean, it's nothing that complicated to be able to see that, well, you can choose u equals cosine and then square u. But if you're a beginner, well, that might be something that you might not think about just yet. So yeah, I hope that I have been able to, just help you a bit. So yeah, that's been the entire video. I hope that you enjoyed it, and see you in the following one. Bye.